For those of you who cannot read the fine print without glasses, have you ever wondered why that is? Let's find out. Hyperopia, also known as farsightedness, is the refractive area of the eyeball where the eyeball itself is actually too short, thus causing nearby objects to be out of focus, whereas objects in the distance remain in focus. This is what a natural eye would look like. The light beams would be focused on the retina. This is a hyperoptic eye. Notice that the light rays converge behind the retina. This is because the smaller eyeball has a larger focal length than the normal 25 centimeters. To correct this, we will use the thin lens equation to find out what the power of the corrective lens should be. Using this diagram as a reference, we will begin with Snell's law to derive the thin lens equation. We start with Snell's law, then we take the small angle approximation to get rid of the sign. From the diagram, we know theta is 1 and 2. Then we rewrite Snell's law with theta is 1 and 2. From the diagram, we know tangent of alpha, tangent of beta, and tangent of phi. But for paraxial rays, D approaches 0, so alpha, beta, and phi are as is. Combining the rewritten Snell's law with the above alpha, beta, and phi, we get the following equation. Then for a spherical surface, we get the following equation. After that, the rays are incident on the surface from within the lens, thus the following equation. For thin lenses, T approaches 0, which results in the final equation on the page. Then we add some equations together and replace object distance and image distance to get the thin lens equation. The power of the lens equation is given to us. A quick example of the thin lens equation would be having a near point of 150 centimeters and finding the prescription to restore normal vision. Plugging in 0.25 for the normal and negative 1.5 for the near point of the hyperoptic lens. We get 3.3 meters to the negative 1 power. Plug that into the power equation to get 3.3 diopters, which is a positive number, resulting in a converging lens. Well, there you have it. To correct farsightedness, hyperopia, just use a converging lens with the corresponding power for your individual needs. Fun fact, converging lenses are just magnifying glasses. Therefore, people who wear them tend to have eyes that appear bigger than they actually are.